Assalamualaikum warahmatullahi wabarakatuh. So we are from Group 1. We will present our PBL 2, which is the Navigating Railway Maintenance Challenge to improve the efficiency. So we with the title of Tunnel Maintenance for the Maintenance System. For the overview of our presentation, so first we will have about us, the research and analysis, challenge during the maintenance, innovative solution, feasibility studies, and the conclusion. Okay, now I will present our organization chart. So first, as the chairperson, me, which is Ahmad Fikri Irfan Mat Jaafar, and then our secretary Muhammad Ilyas bin Roslin. Our first facilitator is Muhammad Nazif Aiman bin Muhammad Izam Shah. Our second facilitator Lianman Edmund Lajuta Tubong, and then our observer Muhammad Isa bin Muhammad Safri. Now for the first slide, which is the research analysis. What is the importance of efficient tunnel maintenance? It is to ensure the safety, reliability, and operational efficiency. It also to observe the impacts to the passenger experience and the overall of the railway performance. So for the overall overview of our project presentation is to understanding the tunnel maintenance challenge, research findings, and strategies for improving the tunnel maintenance efficiency, and the conclusions, also the recommendations. What is tunnel maintenance? Tunnel maintenance is the regular inspection of tunnel infrastructure for the signs of wear and tear, damage, and utilization. It also to the repairing and reinforcing the tunnel structures to maintain the structural integrity and the safety. It also to clearing the debris and other obstruction from the tunnel entrance. It also to monitoring and maintaining the tunnel drainage systems to prevent the water accumulation and damage to the tunnel. It also for the ensuring the proper functioning of lighting, ventilation, and emergency system within the tunnel. Now, how to understanding the tunnel maintenance challenge, impacts, and also how to improve the efficiency. So first, simple overview of typical tunnel maintenance challenge. We have three, which is the accessibility, safety, and also communication and connectivity. So for the impacts on the railway efficiency and operations, we have delays and service disruptions, increase the operational costs, and also the potential safety risk for the passengers and the personnel. So how advanced technology can improve the efficiency? We use the sensor, robotics, and also skill development. For the sensor, we can use like piezoelectric sensor. So I think I will pass to the next presenter.
So Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Isa bin Muhammad Safri, and today I will briefly explain regarding challenges in tunnel maintenance process. A little bit overview, which is we are going to face few challenges, which is accessibility and also safety challenges, and also communication challenges. Alright, so now we are going to start with accessibility, which stated in our slide is railway tunnels are often operate in confined space, and making it more challenges for maintenance crews to access certain areas. Not just the maintenance crews, and also the machinery that we need to use for the maintenance process. So the first challenges we have to face, which is equipment size and also mobility, such as machinery, vehicles, and tools that we need to take inside the tunnel. It may need to be specifically designed or modified following the specification of the tunnel size and so on, to fit within the limit space of railway tunnels, to ensure that we can execute the maintenance process accordingly. And then we're moving on to our second point, which is impact on work efficiency. Crew may need to spend more time navigating tight spaces and setting up equipment, because the equipment may big, but it comes in modular style. So we need to kita kena letakkan dia dalam, kita kena gabungkan dia dalam bentuk satu modular, iaitu dalam cebisan-cebisan, dan kita perlu sambungkan dia. Itu akan memakan masa lah untuk coordinate movement to avoid congestion berlaku ketika maintenance process. Alright, so now we moving on to the safety challenges, which is safety. Seperti yang kita tahu, ia amat penting, kepentingan yang sangat tinggi ketika menjalankan satu proses membaik pulih. Dan juga safety di dalam tunnel juga merupakan perkara yang perlu dititik beratkan, kerana di dalam tunnel iaitu underground sangat bahayalah, especially sebab tunnels bawah tanah, which is provide a higher pressure lah. And also bila higher pressure tu, tendency untuk the structural integrity of the tunnel tu adalah compromise. So untuk structural integrity, maintenance activity must include a regular inspection to identify signs of corrosion of the tunnel, cracks or other structural defect lah that could compromise the tunnel stability. Contoh dia macam cement, it's not a cement, it's actually a concrete block. A concrete block tu dia kalau dah lama, so dia akan lama-lama dia akan berlaku proses deterioration lah. And then we moving on, since we focus on railway tunnels, electrical hazard is there. Contain electrical system for lighting and signalling and also traction power lah, posing the risk of electric shock or electrocution if safety procedure are not followed. So adalah safety procedure yang perlu diikut, iaitu seperti menetralkan bahagian tunnel yang hendak kita melakukan proses maintenance tersebut. So ke situ akan mengurangkan risiko untuk berlakunya kemalangan. Itulah challenges dia, iaitu keselamatan ketika membaik pulih tunnel. Alright, for the last but not least, regarding our challenges, kita akan fokuskan kenaan dengan communication and also connectivity. Disebabkan tunnel ni biasanya dekat dia dalam lah, underground, ataupun go through the gunung gandang ataupun bukit bukau. Communication and connectivity is challenging for railway tunnel maintenance. Sangat menyukarkan, which to facilitate coordination untuk memastikan keselamatan juga, dan untuk kita boleh melakukan real time monitoring lah. Kita nak tengok proses kita di mana dan juga progress maintenance tu. So the first point that kita akan cover, which is coverage gaps and dead zone. It creates from the layout of geometry of railway tunnel, which lead to the weakening communication signal or lost signal. So maksudnya benda ni, tunnel ni dia dekat dalam, so signal untuk sampai ke situ agak sukar lah. So kita perlukan satu teknologi communication dan signaling yang baik dan juga precise lah, untuk dia sampai communication tu, signal itu sampai ke tempat yang diperlukan, which is dalam tunnel lah, dalam cruise, kepada cruise. So dia akan berikan sedikit risk lah, safety risk and hindering coordination of maintenance activities. Communication ni basically macam saya cakap tadi adalah untuk mengetahui status ketika dalam proses maintenance. So and then, since saya cakap ini adalah railway, since railway mostly adalah beroperasi dalam keadaan dengan menggunakan elektrik. Bila mention kenaan elektrik, so akan adanya elektromagnetik. Bila adanya elektromagnetik, dia akan hasilkan EMI, electromagnetic interference. So interference daripada elektromagnetik ni boleh mengganggu signal yang datang. So for lighting, electrical system for lighting, signaling and traction power, which can produce electromagnetic field, seperti saya sebut tadi, that interfere the communication signal. So punca sebab hasil daripada interference ni akan mengganggulah reliability of the data transmission dan menyukarkan lagi proses maintenance, dan juga akan makan masa lah. So untuk hindarkan benda ni adalah untuk melakukan bukanlah sedikit tapi melakukan specific insulation kepada komponen-komponen yang mempunyai electromagnetic interference. Itu saja daripada saya. Saya akan undur diri dulu dan saya pass kepada the next presenter. Terima kasih.
So let's proceed with the 4.1, which is to explain one of the innovative solution that our group has proposed, which is the robotic maintenance and also inspection. So to begin with, I would like to explain few features regarding the robotic maintenance. So robotic maintenance is basically a maintenance that is being done by using or by utilizing robots or any specific machines by in also deploy them in specific condition or environment that the workers need. So first, it is used for predictive maintenance. So it doesn't need any human intervention or human inspector to enter the tunnel. So basically, this robot is geared with camera, sensor, and also laser scanner, so they can perform thorough inspection or whole inspection on the tunnel. So these benefits, especially in terms of the number of frequency of inspection, where we can increase the frequent, and also in terms of the data collection, that where it will be much more faster. And then in terms of the inspection data, it also can be examined by the AI itself, so it can detect any flaws, any minor failures, and also deterioration of the structure itself. And then to the second point, which is to also promote promote remote and maintenance based inspection. So as we know that the specialized robot also are programmed with specific maintenance tasks, so they can do perform such as cleaning, painting, and also making repairs. So in other cases, the robot can also be employed in very far places or difficult to reach places where it is considered hazardous and also dangerous for human workers to enter. So, and at the same time, if the robot is implemented in that area, it will be more effective compared to the conventional ones. So, all in all, this can increase productivity. Right, now let's move on to the third and the last point. So for the third one is to also it has provide with continuous parameter monitoring. So as we know that in designing a tunnel, it is very important to consider parameters. So these parameters involve such as the structure itself, the air quality, the pressure, and also other aspect related to the humidity and also the structural integrity itself. So tunnels may be continually monitored by this uh, robot. So it can also provide inspection in terms of the structural health, the water leakage, and also the air quality itself. So this helps in identifying the minor failure or the early indication of failure, so we can identify them before it's escalate to a worsen condition. So this standard structure condition may also be evaluated by this robot using the non-destructive testing. Moving on to the last point, which is the robot can also integrate with other systems. So robotic inspection data will be integrating with the BIM itself, the building formation model, and then also the asset management system, so they can provide these transportation planners or agency with an overall tunnel condition, uh, which is to improve in terms of the maintenance planning, the scheduling, and also in terms of budgeting, so they can reduce any unnecessary costs, reduce any uh, labors costs, and also energy that is required for maintenance.
Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, Abid to our lecturer, IR Mustafa Kamil bin Omran. Now I will continue to present for my part, which is 4.2. That is the suggested solution or innovative solution for railway tunneling maintenance. I will explain more on piezoelectric sensor on railway tunneling maintenance. So, shall we start?
In this particular topic, which is piezoelectric sensor in railway tunneling maintenance, I shall explain about these 4 points that are structural health monitoring, dynamic load and interaction analysis, track condition monitoring, and lastly, environmental monitoring. Okay, let's continue. First of all, for the first point for this innovative solution for piezoelectric sensor is tunneling structural health monitoring, where the piezoelectric sensor acts as a vibration analysis that are embedded in the tunnel linings to monitor vibration and detect structural anomalies or deterioration in real time. Also, for crack detection in railway tunnel, piezoelectric sensor are used to detect fracture formation and growth by measuring the minute stress change that occur as crack develop and propagate. Okay, the second point is dynamic load and interaction analysis. Dynamic load monitoring, where installing piezoelectric sensors at strategic spot throughout the tunnel to measure the dynamic load imposed by passing trains, which will aid in assessing track and structural integrity. Furthermore, the wheel rail interaction. These sensors are being placed on the track bed to monitor wheel rail interaction, which can offer information on wear pattern like wear and tear, derailment hazard, and also track maintenance requirement. Okay, the third point for this innovative solution part is track condition monitoring. There are two subtopics in this part, which is rail stress measurement and track alignment. For the rail stress measurement, piezoelectric sensors can be embedded in the track to measure dynamic loads and stresses, and helping to identify areas with potential risk of a rail fracture or deformation. The second part is the track alignment. By assessing the stress distribution along the rails can be used to monitor change in the track geometry and alignment, as well as to identify a sign of misalignment of the track and also the subsidence. Okay. Last but not least, the environmental monitoring, where seismic activity detection include in this solution. The seismic activity detection, where applying piezoelectric sensor to track and identify the seismic activity or ground change that could compromise the stability of a tunnel, and also acoustic emission, where piezoelectric sensor capture the high frequency acoustic signal emitted by the tunnel structure, which can indicate early sign of material fatigue or failure. I think that's all for piezoelectric sensor in railway tunneling maintenance. Uh, Proceed with the next presenter.
Assalamualaikum. My name is Muhammad Jasmine Rusdi. So for the third innovative solution, I'm going to explain the mobile meetings management app. So this solution is being employed by many companies such as Traders, Alstom, and Siemens. So this app, this technology, this solution can improve the efficiency of the workers in doing maintenance work. So a further explanation will be explored in the next slide. Thank you. Okay, so one of the benefit of using this technology to assist the worker doing the maintenance work is it able to centralize data access, which means that the worker can have instant access to centralized database of inspection report, maintenance schedule, historical data, real-time sensor reading. So this will able to help the worker to have a quick access to the schedule, which they will only have to open the apps to know when the maintenance should be done, and you can read the reading of the sensor to know if there any fluctuation of the reading, which you, he can refer to the historical data, so that he know that that part might have some defects. So it can be helpful to the workers to have a uh, quick judgment for the part that they do. So another benefit that this technology can help is data recording and reporting. So workers can record the data on site. This, for example, photograph and notes and measurement. So when the workers going to the sites or in the tunnel, so they can take a photograph and uh, upload the photograph into the apps. So it can have a direct the person uh, on the HQ can able to know quick from the workers. So the workers might can apply a quick maintenance that can notify the HQ the defect quickly, rather than uh, the workers need to go back to the HQ. So there are so for the next benefit to be explored in the next slide. So for the other benefit that can this technology bring is work order management. So uh, the maintenance worker is able to receive notification about new tasks, update on instrument, and reminder for scheduled inspection. So this app also connect with the sensor on the train. For example, the train that Alstom use, where it will update the situation uh, when the train go through the track, it will check at will check will the the sensor on the train can check the track in the tunnel. So we can give a real time data. So from that, you can transfer the data into the apps and give quick update. So the worker is uh, able to uh, take an immediate action to maintain to maintain the inspection, to inspect the track. Uh, so for the next is GPS and geotagging. So by using the this app, the worker will be able to geotag the exact location of the defect or maintenance activity. So this able to help quick. Uh, it will be able to help for the OCC to know where the maintenance is being done, where it can help the OCC make a decision and know the location of the workers. That is for me for the third innovative solution, which is a mobile maintenance management app. Thank you.
Right. So for the next part, which is the feasibility assessment on the robotic inspection. So there are 3 points. So the first point is about the cost effectiveness. So as we know that robots, they are quite they're quite costly for initial investment, but they also can reduce these manual labor requirements, so they can reduce the cost rate itself, and also by streamlining this inspection process, which can lead to the cost saving. And then for the next one is to in terms of the long term viability. So the technical service life of tunnel equipment and also machines are coupled with the potential for automations can also contribute to long term effectiveness, where it can reduce its costs and also minimize the unnecessary cost for unscheduled maintenance. And then for the second one is in terms of the practicality. So there are 3 points. First is the technological advancements. So ongoing research and development and also these initiatives indicates that deployment of robots for tunnel inspection and also maintenance, which highlights the advance in automated inspection and also the other approaches. And then it also promotes operational efficiency, so they can enhance the safety, efficiency, and also focusing on the objectivity of tunnel inspection, which is to maintain the structural integrity and also to ensure that safety becomes a prioritization. So the third one is the suitability, where the use of small teleoperated mobile robots for inspection in the tunnel, which you just mentioned, highlights that the robots is practical in various tunnel environments. So in other words, they can be implemented in many types of conditions. Right. So the for the last part, which is the compatibility with existing infrastructures and regulations. So as we know that there are, the robots itself should be having standards that they should comply with. So the employment of these autonomous robots for inspection maintenance can increase in terms of safety. So they can reduce or they can eliminate the needs for humans to enter hazardous zone or dangerous working environment. So the last one is in terms of the compatibility or the integration with the BIM, just as I've mentioned in the features of the robotic inspection. So they can integrate with BIM model. Also, as we know that BIM is an existing infrastructure management system. So when it integrates with these robots, so it can be more advanced, can be providing with more secure features. And also, they can also enable more data analytical in terms of decision making. So they can also promote better maintenance planning, scheduling, and also the budgeting itself. Right, so now let's proceed with the second part on the feasibility assessment on this robotic inspection. So we begin with the barriers and also the risk, the potential barrier and the risk. So first point that I managed to this is in terms of these technical challenges. So as we know that in robots they are installed with a sensor. So the accuracy of the sensor is questioning has been questioned. So where it is crucial in ensuring that the sensors are accurate and also the data collection system reliable. So for them to provide insight into the facility conditions. And then the second point highlights on the robot design and also navigation. As when we designing robots that is specifically designed to navigate complex facility layouts and also for them to operate in dangerous environment or something that is limited areas for the implementation requires uh, significant efforts in terms of the designing. And then for the next one is the operational challenges. So for robots to operate, it needs acceptance from the workforce, or they needs as we want to encourage the workforce to embrace on the development of robotics and automations. It could also lead to job displacement or job loss issues for them if they are not properly integrated with these robots, and also in terms of the task itself. And then for the last one is to manage the cultural and also organizational changes that is required for them to adopt this robotic and automations element. So where it addresses the requirement and also standard for robot operate. For example, the safety standards and also whether the robots comply with the standards that has been given or has been standardized by a certain agency. Alright, so for the mitigation strategies, I have three. So the first one is in terms of cybersecurity measures. As we know that cybersecurity becomes an issue when we want to implement something that requires AI. So implementing these robust cybersecurity measures to protect robotic system and data from the cyber threats itself. And then for the next one is in terms of the phase implementation. So implementing this robotic and automation in a phased manner. So we can uh, start with the low risk issues, low risk areas. So and then we can after think that it can be upgraded to a more complex environment. So we can implement them there. And then for the last one is collaborative and regulatory management. So in here we engage with the regulatory bodies to ensure that it complies with the standard that has been standardized by the industry itself, and also to form regulation to address any liability and responsibility issues regarding the implementation itself. Okay, that's it. Okay.
Okay, now I will continue for the feasibility assessment on piezoelectric sensor with high sensitivity towards the railway tunneling maintenance. So, shall we start the presentation? Okay, the feasibility assessment on piezoelectric sensor with high sensitivity consists of cost effectiveness, practicality, compatibility with existing infrastructure and regulation, barriers and risk, and lastly, mitigation strategies. So, for the cost effectiveness, we will explain about initial investment, where the piezoelectric sensor can be high in investment due to the need for specialized equipment and installation service. But the long-term savings, which reduce the life cycle cost through preventative maintenance, minimizing the downtime and also major repairs. The operational efficiency for piezoelectric sensor is automated monitoring reduce the need for manual inspections, saving labor costs and also minimizing the downtime. Okay, for practicality, there are 2 points under practicality, which is installation ease and also maintenance. In installation ease, piezoelectric sensor can be installed with minimal disruption to the tunnel operation. And for the maintenance, this sensor themselves require little maintenance, but periodic calibration and also data system check are necessary to ensure the accuracy. Um, the compatibility with existing infrastructure and regulation for piezoelectric sensor can be integrated with existing monitoring and data management system. The compatibility with current technologies can vary, and also some customization may be required. Moving on to the next point, which is barrier and risk and mitigation strategies. So the barriers and risk and also mitigation strategies also included in the feasibility assessment. So the barriers and risk for piezoelectric sensors. What is the barriers and risk? The first one is technical challenges. The installation in difficult to reach or hazardous area can pose challenges. Ensuring the sensor durability in harsh tunnel environments is also a concern. And the data management is also the one of the barriers, which handling the large volume of data generates by this sensor require robust data processing and also storage solution. Last but not least, the mitigation strategies for piezoelectric sensors with high sensitivity is the strategies. One of the strategies is training and education, which we must provide training programs for staff on sensor deployment, maintenance, and also that data analysis can be mitigate risk associated with a limited expertise. And last but not least, the mitigation strategies is a regular maintenance. By implementing a proactive maintenance, uh, by implementing a proactive maintenance schedule for sensors and monitoring systems can reduce the risk of malfunction and ensure the data accuracy. I think that's all from me. Thank you. We will proceed with the next presenter.
So for this part, I'm going to talk about the efficiency assessment on the mobile maintenance management app. So the first thing is the cost effectiveness. So for the initial cost, is a software development or is acquisition where either we develop the app or we can acquire the app from a company. We ask the company to make the app for us. So for the second one is the hardware. For example, the mobile app for the mobile, like a handphone or tabs, that's rugged. That is uh, more rugged since this mobile needs to operate in a harsh environment. So for the operation cost, where the cost on which we can call this ongoing cost for the licensing and subscription fee for the software. So maybe every month we have to renew the apps subscription. So it's one of the operation costs, and I think it's maintenance and support. So the apps need to have a maintenance so that the apps cannot that the app will not be crashed when the workers are doing the maintenance works. So uh, we need to know this operational cost. So for the return on investment, the first one is efficiency gain. So by implementing this technology, we can increase our efficiency worker maintenance worker in doing their maintenance works. And another one is a reduce error and rework. So this can help the workers to do the maintenance work effectively so that they don't have to go to the site again and again to check the problem. And the last one is predictive maintenance. So by using this app, we can apply a predictive maintenance and early stage, so that we can know the defects and help it to prolong the life of the track or the wall of the tunnel. So for the practicality, it is able to help the workers, which is it can have a user friendly interface. So they like uh, the apps can easily help the worker, so you can know where the things that needs to be open. Next is integration with existing system. So this app is easily can integrate with online system. So, for example, the sensor data, physical data, and other things. So you can easily go online and get all this information. So for the operation efficiency, so you can give a real time data access. So we can know the, like I said before, the fluctuation of the reading sensor, and we can able to operate in offline facility. So when there is no an internet in the tunnel, the apps can go to offline mode. So in offline mode, you can also view the data, but maybe you cannot access the real time data lah. So but you can the historical data, all that data can be viewed. And the next one is GPS and geotagging. So this can be locate the where the part needs to be done. Like I said before, that's it for this cost effectiveness and practicality. Yes, I will go another one about the compatibility. Thank you. So for this compatibility with existing infrastructure and regulation, which are this app have the technology compatibility in existing ID infrastructure. So this app is able to support the new mobile technology by including the server capacity, network bandwidth, and cybersecurity measure. So this app is able to operate in in a safe without any disturbance. So for the next one is integration capability. So this app can integrate easily with the current system used for access management, work order management, and data analytics. So that the worker so that the worker can easily access to this information, helping their maintenance work without any needing what we call uh, approval from the rescue. So it can be accessed immediately. So for the regulator compliancy, which are the local regulation, this app which have a compliance to the data security and privacy and railway operation, so that the data cannot be misused by the others. And for the next one is data sovereignty. So this data needs to be stored and handled in compliance with the state, so that the data can be protected safely. So that's is for me. Next, I'm going to explain for the uh, risk or barrier to implement this technology and how to mitigate the problem. Thank you. So I'm going to explain about the risk or barrier and mitigation strategy for implementing this technology on mobile management app. Which the first risk is initial cost and budget constraint. So it admit the cost for this technology might be high at the first stage. So we suggest how to mitigate this problem is phase implementation, where we start these apps at a small scale, at a specific location, and if it bring a great improvement, then we move to the next phase, so that the budget so that we can reduce the cost, uh, so we can reduce the cost of the implementation of this technology. Second is using a leverage government grants or subsidy. So we can propose this technology to the government, and getting a subsidy from it by explaining to the government the benefit of this technology, which might help improve our maintenance work, and also improve the longevity of the equipment. For the third one is a cost benefit analysis. So for this one, we can go through truly cost benefit analysis to justify this investment can bring a long term potential in saving costs and gain a great efficiency in doing the maintenance work. So for the second risk is a connectivity issue. So for the first one is a offline facility. Uh, so if there is no connection, if the worker are going through a very deep tunnel, we have an offline facility where the worker still are able to access the data without any can of or can get the data without any disturbance. So the data is still there. Only the real time data does not show. So it still can help the worker access the data uh, without online mode, without the online real time data. So for the second one is a signal boosting technology where we can invest in this technology to enhance the connectivity within tunnel. So for example, we might put this technology outside of the tunnel and improve the connectivity through the tunnel. So for the third one is predict data sinks. So this predict data sync is able to help the worker to synchronize with the current data when there is a sudden uh, internet connection. So it will update the data uh, immediately. So this can help when the internet connection is unstable. So whenever the worker at a specific place where the internet connection is better, it will update the data uh, immediately. So that is from me, and thank you for listening throughout through this video.